please don't talk. Angle of inclination, if you put your finger positive x-axis and go anti, you hit that is inclination.
Oh, yeah,
Yeah,
I
just
got
check.
that. I'm proud of myself.
Move this. Guys, you mustn't talk because everyone can hear you. Okay. If in the shape of an N, then you can see the angle of inclination will be an obtuse, bigger than 90 degrees but smaller than 180. Whereas if the gradient line is positive, I think you can see it's going to be acute. If the gradient of the straight line is positive, to get that angle of inclination, you shift tan, you put the gradient angle. How negative, you show gradient of on the other side. Tell them what the acute angle is, but then your angle of inclination, you just go 1 minus that acute angle. Now, for the first part of the lesson, every example I'm doing from your textbook. So look at page, I don't know if I have the current textbook, 69, words. All right, and you can pick up examples. The first example, just literally, it's actually a worked example. I think it says example 6. It actually says, okay, turn the music off, guys. Guys, turn your music off. Music on while you're studying anyway. Right. Determine the angle of inclination. Guys, please don't talk.
Okay, ma'am,
Of
sorry.
line segment from P to Q. Now, you do not have to draw this. I just want you to see it. You do not have to draw it, but just see what I am saying or what I'm asking you. If you, from the plot these two coordinates. So point P would be when x is 2 and y is 1. So point P would be there somewhere as a coordinate. Would be when x is minus 3 and y is minus 3. Down here somewhere, okay, minus 3. If I join those two coordinates, not quite sure, okay, according to the textbook, the y-intercept, just so you know. Okay? When they say declination, if they give you a diagram, you could quickly plot to be from the positive axis to now I'm going to get a okay, but let's say you did not know that. Let's say you didn't draw. Then you will see by doing the gradient of PQ, remember you go y of, let's say, P minus the y of Q over the corresponding. Once you will see that. So I'm going to take 1 minus this value. Be careful when you minus a minus over the x value. Got to go back up to point P. Minus this x value. Okay, nearly made a mistake there. All right, so we're going to get 1 plus 3. So the numerator will be 4. 2 plus 3 is 5. So my gradient will be positive 4 over 5. Now, I was expecting the gradient to be positive because, look, it's like a tick. That straight line has a positive gradient. So therefore, I know that the angle of inclination will be acute. So we use the formula, you take the gradient of the line, which is PQ, and it's going to be tan of the angle of inclination. So the gradient is 4/5. That will equal to tan of this angle of inclination. Now, tan theta is a ratio. Do you understand? If I want to work out the magnitude of the angle theta, this is where you have to press shift. So we need a calculator, and we're going to round this off where necessary to 2 dPs. So once your calculator is on and you're in the right mode, just go shift tan up to 5 equal. So the angle of inclination theta is 38,659. So that will be 6 degrees. In your textbook, they did it to 1 decimal. Guys, don't talk. In your textbook, page 69, as a they did it to 1 decimal digit, 38,7 degrees, because they rounded it off to 1. Your textbook is actually written fundamentally for the IEB students, the independent examination. And their exam instruction is always to 1 decimal place. Yes. Do I have a question?
I said, please repeat, ma'am, what you said now. You're breaking up.
Okay, I just said that your textbook on page 69, that exact example, it just rounded it to 1 decimal place. That's all. Okay, so let's take another example from your textbook. So you, after the lesson, the next example, they asked for the inclination. See, I'm using your textbook. They said from points M, -1, -1, and N, which is 5 and -4. Now, when you do examples, I guarantee you the diagram will be there. I've never in my life seen an angle of inclination without a diagram. Just for interest, if I plot those two coordinates just very roughly, x being -1, y being -1, so n would be approximately there, and n, x is 5 and y is -4, which would be down there somewhere. So let's just make that n, and y is -4. If I join those two dots, but then I must also extend that, angels, to my x. So using my ruler, if I join that dot, I'm going to extend this line. So even if it's a line segment from there, if I can't on a straight line, then you've got what they're asking me for. Sorry, that's not the nicest line. They're asking me for that angle there. From the positive x to the line is basically from the x-axis. Just say the x-axis, but you can see it's obtuse. And you can see that the gradient is going to. So remember, this is when you've got to get this angle, and I'll side, and then just minus the acute. First of all, you get a mark or 2 for giving them the correct gradient of mn. So the n, we take the y of the one minus the y of the other. Be careful when you matching x of the first coordinate minus the x of the second. One in the denominator, over 6. Now you must simplify that to we all understand that is the same as -2/3. Now you can see that the gradient is negative. So if they put you from scratch into your formula, gradient. Now, to get the angle, which is not the angle of inclination, because look, it's on the left. made it positive, then you tell them this equals to tan. Have the so, listening, Angel.
Ma'am, you copied down is wrong when you
Did I?
where it says M of M and N.
4 minus 1 minus 1.
The first step.
Onion for you. Lamb chop was watching. Okay. I copied that down wrong, or I did the wrong thing. Okay, but a deliberate error. To see if you were watching. Again, the gradient of MA. It's going to change. Still going to be negative though. For your y, maybe I use the x's first. What I just did is what you so gradient is y minus a over the x minus the x. So we're going to get minus 4 plus 1, which is minus 3, over 5 plus 1, which is 6, which simplifies to negative a half. Thank you, Angel. That gradient is negative a half. Okay, however, having got the gradient, to find the acute angle, just make the gradient positive. So positive a half, not negative, positive a half equals tan of the acute angle. So now just go theta acute. So remember, to get an angle, you need to go shift tan. So on your Casio, you're going to go shift tan, up, down, put the positive gradient, and get this to be 26,57. I've rounded it to 2 decimal places. So your angle of inclination, which is going to be an obtuse angle because the gradient is negative. Do you see you're going to go 180 degrees minus 26,5? And if I do that on my calculator, this angle of inclination will be 150,43 degrees. Now the textbook will have done it to 1 decimal place. So round off to what they say in your exam. Okay, I'll just check I got that right. 153,4. Did the 2 work examples that they actually show you? They don't really show you 6,57. They just go 180 minus the 26,57. So as long as you understand, to get that acute angle, I just put in the positive gradient. All right. There's a lot of examples here. You're welcome to do them. Exercise 3. So you can do this for homework. Exercise 3, A through to E. The answers will be at the back. But guys, that is exercise 3, number 1. Now sometimes we use angle of inclination backwards. So if the gradient equals tan of the angle of inclination, if you know the angle of inclination, let's pretend the angle of inclination was 30 degrees. Then the gradient of that straight line would be tan of 30 degrees. Now, tan of 30 degrees, I know it's a special angle, it's 1/3, but remember with analytical geometry, we will always use decimals. Now, notice you not press shift if you have an angle looking for the gradient, which is a... So if you have the angle inclination, you can get the gradient of the straight line. But don't press shift. So I know that tan of 30 is 1 over sec 3. Just to prove it to you, if I go tan 30, look. Oh, your calculator will rationalize that. Do you remember rationalizing the denominator? So your Castel will give you that. But then if you press SD, the gradient is going to be 0,577 blah blah. And this textbook is going to everything, I think, to 1 dp. So it would be 0.6. Okay. Now, I just made that example up. I'll do the first example, which is 2a. All right. So from exercise 3, in your exercise A to E is going to be just formula like that. Each time, get the gradient, press shift. Exercise 2, they want the gradient, but they're telling you they give you the angle of inclination. So the first thing, okay, so what straight inclination. It's a bit noisy. It's like there's a TV. It's off. Background. Thank you. Now, I just want you to notice that they gave me, do you see, is not sure exactly where the straight line is going, but the angle of inclination is obtuse. So I can already tell you gradient. Easy to go backwards. So you use the formula gradient of a straight line equals tan. So you just press tan 135. So if you're looking for the gradient, don't press shift. And if I go tan of 135, I get, just for interest, if you did reduction, we've done trigonometry, degree 135 is in quadrant 2, tan's ratio would be negative, and you would get negative 55. It's trig, but it's, well, it is trig, but it's in analytical. So because it's analytical, I don't know if it's necessary to show them that step. But if it's trig, in the trig section, you have to. Straight minus 1x and plus the y-intercept. Now, I don't have enough information. They didn't tell me any coordinates. They didn't give me any coordinates, so I couldn't find the full equation. But the question was, find the gradient of a line with an angle of inclination of 135. Let me do one more example. I'll do number B. They said if the angle is 45 degrees. So do you agree that is an acute angle? So the gradient will be positive. So gradient equals tan of angle of inclination. That's a special angle. We know the ratio is 1. So therefore the gradient is just 1. So they said, what is the gradient? Okay, so those are very easy examples. You can practice them. Yesterday, I showed you a better examples of how I predict it's going to be asked in your exam. They could ask you for the angle of inclination, sure. Or they could ask you a slightly more complex question. I'm going to just make this one up, but it's going to be very similar to what I did yesterday. So, sort of as hard as it can get is, sorry, I'm just looking for my pens. That's probably under my textbook. Yeah. Let's say they give me 2 straight lines. Now, guys, I'm making this up, so I don't know what the final answer is. But let's pretend this straight line, let's call it the line AB. Let's say they give me the equation, y equals to x plus 1. Then I have another straight line. Let's make it here somewhere. And this is not, oh, that didn't work. This is not drawn to scale. Please take note. Let's make it the line CD. And let's just say this equation is y equals to minus 4. Right. Now, they might say for you solve for theta, but theta is going to be off the x-axis. Please take note, that is not the angle of inclination. But we will find it, and it would be at least 4 marks using angle of inclination, and also look for a triangle. So I'm looking for a triangle. Do you all see this triangle here? Okay. So the gradient of this red line is 1. So gradient equals, okay, so do you see the gradient is 1? So so you have, let's say, alpha in your diagram. So you're looking for that. And if you go shift tan 1, then you'll get 45 degrees. All right, so that angle is 45 degrees. That angle is 45. Just this. Now, this straight line here, the gradient of the line CD is -2. Now, you've got to find the acute angle first, because let's just go acute angle beta, sorry. Do you understand this angle here is actually the angle of inclination? To get the acute angle on the other side, if you remember, plug in the positive gradient, not the negative, and you will get tan of the acute angle, which I'm just calling beta, because there is no other beta in this diagram. So I'm calling this little angle beta in my diagram. And I acute angle positive. So if I just go shift tan 2, acute angle here. So you say beta, not tan beta. Remember, tan beta is a ratio, 2:1. So a trig function is a ratio. If you're looking for an angle, shift, and then you're getting the degrees. Shift tan 2. So the angle is 63, let's do it to 2D, please, 3 degrees. So that would be that angle. Now, do you would be so in this little degree theta would be 180 minus the sum of those 2 little angles. Here I am using some angles in this triangle there. Sometimes you can use the exterior angle. It's up to you. But degree, they said, what is theta? Let me keep it blue. Sorry, I've got a color coding here. So the angle theta, which is there, degree will be 180 minus the sum of the 2 acute angles, 63,43, and add the 45 degrees. How do I know that? Because of some angles triangle. Which triangle am I talking about? This tiny little green triangle. All right? So if I just go 180 degrees minus open bracket 45 plus 63,43 close bracket, then this angle theta here is going to be estimate 71,57 degrees. So if they had just said, determine the angle of inclination, level 1 of this red line, they just want that angle between the x-axis and the line. M equals tan angle, but you can't use theta, remember? If theta's there and that's alpha, you must use the correct variable. So the gradient I got from the equation, it's a ghost plus 1, the coefficient of x. So 1 gradient equals tan alpha, shift tan 1, alpha is 45. So if they want angle of inclination, that's easy. If they want an angle that is off the x-axis, you normally have to find a triangle. All right. I'm going to start looking at this worksheet. This worksheet here I'm going to post on the group. The angle of inclination question is very clever. They have a clock. Now, I know a lot of you are not used to clocks with long hands and short hands. Let me remind you. I think it's called an analog clock. I can't even remember, but not digital. So when you get this question, I want you to ignore what you see below the x-axis, okay? So the x-axis, they actually give you the equation of the hands. So if you look at the long hand of a clock, it's a straight line. So I could give you that equation and you could find the angle of inclination, all right? And then they're going to give you the equation of the short hand and see what you can do. And then they're going to ask you what is the time. It's an IEB question. It's very clever. The first 3 questions are revision of just stuff we've done already. Okay, so I'll start the lesson by showing you it's not just angle of inclination, but this is a very clever question when they ask you to read off the time. All right, so as far as what you do after the lesson, so in the textbook, just look at page 169, I think it was, not 169. Let me just double check. 69, I think I said. Yeah. And guys, you're welcome to go couples. You can always go past 169 to 170 and work through those examples. The answer, you'll find the answers are at the back. As far as this worksheet, as I said, I will post it. I'm sorry, I just want to get pressed in. Okay, so it's from an IEP exam. The first question, you can't see it from there. It says M, the coordinate is 1 and B. Is the midpoint, this is what they give me. This is question A, of the line segment, and then they say point A, the x value is unknown, little a, y is 4, and point B, we have the full coordinate. And the question is, can you please, that is a little b, not a 6. So the question is, can you please determine little a, which is the x part of the coordinate of A, and little b, which is the y coordinate of M, and M is the midpoint. Now, you don't have to draw this, but what I would do is I'd put point A on the end. I would put M in the middle, just so you know it's the midpoint. It's in the middle. And I'd put point B on the right. We actually did an example exactly like this, if not the same. Now, remember midpoint, you take the 2 x's, add them up, divide by 2. Remember, it's the average, add them up. Take the 2 y's, add them up, divide by 2. So the x value of this midpoint, which we know is 1. Let's actually set up an equation. So we take the endpoint, which is a, we add the x point, which is 5. So these are the two x values. That's the y value. You know a coordinate always goes like that. This m is your midpoint, and that is the x, that is the y. Now the formula tells us if you add the two x values, so I'll go over them in a color. If you add that x value to that x value, and what's the rule? If you divide that by 2, what will you get? You will get the x value of the midpoint given. Put that over a ghost 1. Remember, that's a flat bracket. My LCD flatten is 2. So a plus 5 equals to 2. So a is going to be 2 minus 5. So you will get a is negative 3. Guys, we can check that. Minus 3 plus 5 is 2. Divided by 2 is 1. Now, take the y of this point, add the y of the end point. If you divide that by 2, you will get little b. Guys, that's a 6 and that's a b. I hate b's and 6's in the same question. So 6 plus 4 is 10, divided by 2. So little b is 5. Okay, I've got minutes. The second question from this IEB exam, written at private schools. This exam was 1999, so I don't think you guys were even born. 1999, sure, 21 years ago. All right, I actually, however, have done question B in a previous question. I will remind you, it gave us point C, which is 1 and negative 2. It gave us the point D, which is 5 and 1. And it said the coordinate, of E, the coordinate of E, the x value is little c squared, and the y value of the coordinate is c plus 1. You should have a vague memory trace of this question. And the question was determine the values c if, and then they said point C, D, and E are collinear. Guys, remember, collinear means they lie on the same straight line. So either the gradient will be positive or negative, but you solve collinear, solve it by using gradients. Because the gradient from C to D will equals the gradient from D to E if they are collinear, meaning they lie on the same straight line. The gradient's constant. So guys, we've got 2 minutes. You can finish this at home. So you're going to find the gradient from C to D. Remember, you're using the formula y of, let's say, D minus y of C over the matching x values. And then you must find me the gradient of DE, and there's going to be the variable C in that. Then you take the two gradients and you make them equal and you solve for C. If I remember, it's a quadratic trinomial. Okay, so lamb chops, I'm going to photograph this page. You could read your number A. I did put the answer on the board. I will send you the memo tomorrow, because tomorrow I'll just read you number B, I'll do number C, which you must try, and using the angle of inclination, read this question. They want to know for a total of 7 marks. They first want to know to the nearest degree the inclination of the hour and the minute hand. That's the angle of inclination of the minute hand is the long hand and the hour hand is the short hand. But they give you the equations so you can draw that. And remember, a clock, the y-intercept would be the origin. So, for example, the long hand might, for example, be there and the short hand there. I'm making that up. You've got to read that more carefully. And then it's going to ask you what is the time. Okay, I love you guys. Tomorrow, I think I'm going to go back to a bit of analytical geometry and also a bit of trigonometry. We're going to just revise the two again. Bye.